Okay guys, let's go ahead and do this one, Q5. I do apologize for uploading this video without audio. Not sure what happened there with the mic, and I'm actually hoping that this one is actually working also. Let me actually double check and make sure. No, the notepad is not working. There it is. Okay, so this one right here, I got a linear function, and it's telling me that I'm translating it 8 units down. So remember, when you go up or down, you're going to add or subtract to the number outside. So here's the function, okay, and this number, the +1, is the number that's outside. Okay, so if I'm going to translate this 8 units down, I'm going to subtract 8 from this +1. So 1 minus 8 is -7. So if you go to your answer choices here, clearly this one right here is your answer. Okay. Now this one, I'm translating 3 units to the left. Okay, so if I'm translating to the left, I'm going to be adding 3, right? And that's going to be to the inside, so not the number outside. The -9 is outside. Okay, so if I'm going to add 3 units inside, that's going to be to this guy, the 3x. Now what's that going to look like? Okay, so here's where my notepad comes in. Okay, so I'm going to have 3x minus 9, because notice this is a linear function, right? So, whoops, I didn't type. There it is. 3x minus 9. Okay, if I'm going to add on the 3 units on the inside, this would be 3 times x plus 3 minus 9. Okay, next I distribute that 3 inside, so that'll give me 3x plus 9 minus 9. Okay, because again, I distribute that 3 inside, so 3x, and then 3 times 3, that's 9, and then minus, not 0, 9. Okay, now that +9 and that -9, combine like terms, those will just cancel. So then the answer would be just 3x. Okay, this is what's happening because this is a linear function. Okay, so you're just plugging into that. Okay, so 3x. Next one, whoops, sorry, I still have this one enabled, but anyway, got it correct. In this one, they're telling me I'm translating 17 units to the right. So if I'm going to the right, I'm subtracting 17, okay? And to the inside, notice that this is a quadratic, right? Now, if I subtract 17 on the inside, that's this right here, okay? So the +10, I'm going to subtract 17. So 10 minus 17 is -7. So if you go to all of these here, that right there is the only one that has -7, so that's your answer. Okay. Now this one, they're telling me I'm translating 4 units to the left and 11 units up. And notice this is a linear function again. So if I'm going to be translating 4 units to the left, I'm going to add 4 on the inside. So that's the inside right there. And then 11 units up, I'm going to add 11 outside. So 8 plus 11. So let's go ahead and go to our notepad here. So I have -3x plus 8. So if I'm translating 4 units to the left, I'm going to have x plus 4 on the inside. And then there's the +8. And then plus, I'm translating 8 units up. Okay. Now, in the first part here, I'm going to distribute the -3 in. So then I'll get -3x minus 12, and then +8 plus 11. Combine like terms, that -12 and the 8 and the 11, those are all like terms right there. When you combine those 3, you should get, let me see, that'll be -3x plus, let me see, that'll be -1, 7. Getting 7. Okay, so -3x plus 7. If you go to your possible answer choices here, that'll be this one right here. Okay. Next one, translating 7 units down so just 7 units down. So when I translate again up or down, I'm adding or subtracting on the outside. Because I'm going 7 units down, I'm going to subtract 7 from this 9, and that'll get 2. If you go to your answer choices here, this is the only one with the 2, right? So there's my answer. Next one, I'm translating 7 units right. So that means I have to subtract 7 on the inside because I'm going right. So 8 minus 7 is 1, right? And you can already stop right there. This is the only one with a 1 inside. But just to show you, right, negative 5, if I translate 4 units down, I subtract 4. So negative 5 minus 4 is negative 9. Okay. Now right here, what ends up happening in these problems is they want you to write in the equation this time. So normally, right, refer to your notes, right? You for both absolute value and quadratic functions, you start from the origin, right? And then, it goes from here. But this one clearly has been translated up, right? 5 units. It's not moved left or right, so it's just up 5 units. So then that should be x squared and then plus 5. Okay, this one has been moved to the right, right? From the origin, you move to the right 3 units and then down 1 to get to the vertex. So if I move to the right 3 units, I'm going to be subtracting 3 inside. Okay, x minus 3 squared. And then I move down 1, so minus 1 outside. Okay, and don't forget the little square, right? It is a quadratic. That should do it. There it is. Okay, this one is an absolute value function. Again, these also start in the origin, but this one has been shifted to the left 9 units, right? Not up or down, just to the left to 9 units. So if I move to the left, I am adding, and here's the function equation, x plus 9. Okay, so I should get this correct. There it is. Okay, this one, we're back to a quadratic. From the origin, I've shifted to the right 3, and then down 4. So if I went to the right 3, that's going to be subtracting 3 inside, and then down 4. So minus 4. Okay, I'm almost done. Here, from the origin, I shift to the right 4 units, and I didn't go up or down, so it's just to the right 4. So then that should be x minus 4, and it is a quadratic, so don't forget the square. Okay, and this should do it. There we go. Okay, now this one has been reflected across the y-axis. So remember, if you reflect across the y-axis, that's only on the inside where the negative goes. It's not the whole thing. Okay, so the negative inside will change. So this x becomes negative. Okay, so actually, let me show this on the notepad where it might be more clear. Okay, so here's what I have, right? Negative 9x plus 3. If I'm reflecting over the y-axis, that means you're making the x inside, like this, negative, okay? And then if I have negative 9 times negative x, well then those will just become positive. But the plus 3 was left alone. You didn't touch it. Okay, so then this would be the equation of this 9x plus 3. Okay. This one was translated 3 units up, so the number outside, I'm going to be adding 3 to it. So then everything else stays the same, not touching it. I'm just going to be adding 3 to the value outside, so 1 plus 3, that's plus 4. Okay. This one was reflected across the x-axis. So this time, I'm going to multiply, the negative is outside, not inside. So if I have a negative outside, it's like multiplying the whole function by a negative. So the sign of this will change, and then the sign of this guy will change, because I have to multiply him by a negative and him by a negative. A negative times a negative will make him, there you go, will make him positive and make him negative. Okay, so then 2 absolute value of x plus 1, and then minus 7. Okay, the common mistake here is students might change the sign of the inside as well. Okay, no. When you reflect across the x-axis, okay, the negative goes in front of the function, so multiply everything. So his sign will change, and his sign will change. You leave the inside alone, okay, don't touch the inside. All right, this one now, 3 units to the right. So if I'm going to go to the right, I'm subtracting 3. So then I'm replacing him with an x minus 3. So let me go back to my notepad here. So here's the function I started with. And if I go 3 units, caps lock is on. If I go 3 units to the right, that means I'm going to have x minus 3 inside. So if I distribute this negative 4 in, that'll be negative 4x plus 12. Okay, because negative times negative is positive. And there you go. This would do it. So negative 4x plus 12. Okay, just like that. There you go. This one, reflected across the x-axis. Again, if you reflect across the x-axis, the negative is in the front, which means you multiply everything. So then this right here will change, and this right here will change. So both of them will become positive then. So then you'll have x plus 1 squared, and then plus 1. Okay, now this one, reflect across the x-axis. Again, same idea. You have the negative in the front, so that means everything here will change. So that negative 5x will become positive, and this plus 4 will become negative. So 5x minus 4. Okay, looks like 2 more questions. So then this one, it says write the function rule for g of x. So then this one has clearly been shifted to the right 7. And not only that, it's also been reflected downward, right? It's no longer opening upward. It's now opening downward. So this one will be absolute value of x minus 7, because I went to the right. And, oh, there goes my keyboard. Uh-oh, looks like my keyboard is not working. There you go. Now it is. Okay. Well, that would not have been good. So x minus 7. And then, again, we said, right, that it was reflected across the x-axis. And look at your transformations guide. That means the negative is in front of the function, like I wrote it there. And that's it. No plus or minus outside, because it wasn't shifted up or down. Okay. Last question. So this one has been shifted down 2, right? Not to the left or the right, just down 2. So then this would be absolute value. Well, actually, before I type this in, notice that this one too is more thinner, right? Like thinner, stretched vertically, in other words. And look at your notes, right? We talked about what this looks like in terms of a vertical or a vertical stretch or a compression. So all you need is the slope of one side of the line. So take the right side, because that's the positive slope, right? So this is 1 point. And then next is just pick a point along the next lattice point, in other words, the next corner of a box. Notice that here's a good corner right here, right? So from the vertex to this corner, what's the slope? The rise is 1, 2, 3, right? And then to the right 1. So 3 over 1, that's the slope. 3 over 1 simplifies to just 3. So then that means this one has been vertically stretched. Oops, there it is. Has been vertically stretched by 3. So then absolute value of x, because it wasn't moved left or right, and then subtract 3 because you shifted down 3. Okay, there you go. That would complete the IXL. Okay, so hopefully this helps you guys finish it a lot sooner.